Today we're going to talk about measurement. So we've been talking about the scientific method, and when you're using the scientific method and doing an experiment, you're typically collecting data. And most of the time, the data that you're collecting is numerical or quantitative data. So it's really important that we discuss how do scientists measure, what units do we use, and we're also going to talk a little bit about what's called the International System of Units, or the SI system, which is sort of the adopted universal system that we use for science. It's pretty much the same thing as the metric system, but it's got some slight differences. For example, the metric system tends to use the temperature Celsius, whereas the SI system, the standard unit is Kelvin as a unit of temperature. So there's a few slight differences, but for the most part, you've probably learned this before. This is going to be like the metric system. So let's walk through these parts here. So metric prefixes. So the reason we use the metric system or the SI units is because going from one unit or one prefix to another is simple. You're basically just dividing or multiplying by 10. It's based on tens. So this is not all of the prefixes. For example, these days you know that hard drives are really big, and you know that there's mega and there's tera, and so there's these larger prefixes, but these are sort of the general ones that we just show you in biology. So kilo, hecto, deca, then your base unit, meaning gram, meter, liter, because you could have a base unit like grams without any prefix at all. Deci, centi, milli, and then these three may be new to you: micro, nano, and pico. So these are used in biology, these three, particularly to measure things that are really tiny. For example, micrometers or microns are oftentimes used to measure bacteria. And particles are often measured in nanometers or picometers, and viruses in nanometers and picometers, because these things are very, very small. So in biology in particular, or medicine or things like that, you may see where we're using some of these smaller units that you haven't heard of. Also notice, kind of important, that milli and micro both start with an M, but the unit the prefix symbol, I should say, is different. So for milli, it's M. So if something was millimeters, it would be millimeter, MM. But if it was micrometers, this is a Greek letter mu, so it looks kind of like a U, but it's actually like a Greek M, lowercase. And so this is the symbol for micro. So that's how you would know if it was millimeters or micrometers, which are two different things. A micrometer is only 1/1,000,000th of a meter, very tiny, tiny, tiny size. Whereas a millimeter is 1,000th of a meter. So it's still small, but you can actually see a millimeter on a ruler. You can't see a micrometer. You'd need a microscope to measure micrometers. Also, deca and deci both start with D, deca, deci. However, decameter and decimeter also have different units. Decameter, you can see, is DA, sorry, I gotta get to my pen here, DA for decameter, and that's tens. So a decameter is actually 10 meters. So if you think of a gigantic meter stick, one of those big, long meter sticks, one decameter would be 10 of those, 10 meter sticks. A decimeter is only 1/10 of a meter. So it would be 10 centimeters, or basically a third of your meter stick. So that's a difference between them. A deca is much, much bigger, 10 meter sticks. All right, one way you can remember these, this actually goes all the way up to tera, but this is kind of a cute way to remember them. That great morning, King Henry died unexpectedly, drinking chocolate milk, missing nature's picture. So this is kind of a cute little way to remember them in order. We're not going to be worrying about tera or giga, but you are going to need to know these other ones. So, we're not going to worry about mega either, sorry. So if you can remember that, King Henry died. Now the unexpectedly is the base unit. Sometimes I'll say King Henry died basically. That means meter by itself. Like if you just see a single letter, just to clarify, like let's say I just see M, and you're like, is that millimeter? No, that's just meter. because you have to have a base unit of some kind. The second letter is a prefix. So if I have mm, it's millimeter. If I have the Greek mu, m, that's micrometer. But if I just have m by itself, or L by itself, or G by itself, this would be a meter, or a liter, or a gram, the base unit, without a prefix. So King Henry died, basically, so this would be like meter, or gram, or liter, without any prefix. And then drinking chocolate milk, missing, be careful on that one because it's actually the mu shape, missing nature's picture. If you can memorize that little King Henry died, basically drinking chocolate milk, missing nature's picture, and jot that down, you'll be able to convert between any prefixes very, very easily in this class. So let me show you how to convert between prefixes. So here's our units. King Henry died, basically, this is our base unit, or unexpectedly unit. Drinking chocolate milk, missing nature's picture. Remember, this is actually this symbol, micro. Here's how you're going to convert. Every jump from one prefix to the next, you're going to move the decimal point one spot. With the exception, I'm going to just add it right now, of these three. Milli to micro, micro to nano, nano to pico. This is actually a 3 decimal place move because milli is a 1/1000th. This is 1/1,000,000th, 1 over 1 times 10 to the 6th. This is 1 times 10 to the 9th, or 1 over 1 times 10 to the 9th. And this is 1 over 1 times 10 to the 12th. So notice how it's not just a 1 decimal space move, it's actually a 3 decimal space move. So I would recommend you memorize King Henry died unexpectedly, drinking chocolate milk, missing nature's picture. Just put your prefixes there. You know, King Henry died, base unit, meter, gram, liter. Drinking chocolate milk, missing nature's picture, and then add in 3, 3, 3, because it's actually a 3 decimal space jump to those 3. So let's say we wanted to solve this one. 257.49 decameters, dA, that's this one, to kilometers. Here's how you solve this. It's really easy. You just have to practice. So once you have your prefixes written out, we find deca first. That's here. Now we find kilo. That's here. Which direction do we need to go to get to kilo? We have to go to the left. How many jumps do we need to get to the left? 1, 2. So we're going to move our decimal 1, 2. 2 spaces to the left. So again, you find your first prefix, find your second prefix, count how many jumps and what direction you have to go, and then you simply move your decimal point that number of places in that direction. So in this case, 2 spaces to the left, 257.49 would become 2.5749 kilometers. Now, like I said, micro, nano, and pico, those 3 jumps are a 3 decimal place jump, not a 1 decimal place jump. Now, in class, we're going to practice these 5. So I'm going to rewrite this. King Henry died. This is actually dA for deca. And then it's going to be basically, that's your base unit, which would just be an M by itself, a G by itself, an L by itself, no prefix. Drinking chocolate milk, missing nature's picture. And I'm going to add here 3, 3, 3. All right, watch how this works. This is not too hard. So I'm going from decagrams to milligrams. So I find deca, I find milli, that's here, and then I count how many jumps from deca to milli. Well, I know I'm going to go to the right, so my decimal is going to go to the right. 1, 2, 3, 4 spaces to the right. So 1, now what do you do now? You have to add zeros. 2, 3, 4. So my answer would be 21,000 milligrams. I'd go 1, 2, 3, 4, and this would be my answer. Let's try the second one. 250 milligrams to grams. So milli is here. The base unit of gram would be here. So this time we're going to go to the left. Let me change my color. All right. So from milli to gram, 1, 2, 3 jumps to the left. My decimal in this number would be at the end. Hopefully you know that from your math. That in a whole number, the decimal, even though you didn't see it, is there. 3 to the left, 1, 2, 3, 0.250 grams. Let's look at our third one. Kilometers to centimeters. All right, let me get a different color. So here's kilometer. Here is centimeters. So we're going to be moving the decimal place to the right. Now we count how many jumps to the right. 1, 2, 3, 4, 5 to go from K to C. So we're going to go 5 places to the right. 1, 2, 3, 4, and 1 more. Our answer is going to be 350 centimeters. By the way, you don't leave the zeros before the number. They don't mean anything. You could leave them. It wouldn't be wrong, but nobody's ever seen 350 with zeros in the front of it. So those would just disappear. All right, pico. This is one of our really tiny ones, all the way over to hecto. So let me change my color one more time. Let's do purple. All right, now remember, this one, some of these jumps are more than 1 decimal place. So pico, we're going to go to the left, and here's how you're going to count on this one. It's going to be 3, 6, 9, 10, 11, 12, 13, 14 spaces to the left. I'll repeat that. You have to, these are 3 decimal place jumps. So 3, 4, 5, 6, 7, 8, 9, and then the rest of these will just be a single jump. 10, 11, 12, 13, 14 spaces to the left. So we're going to go 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is going to be a really tiny number. 2, 1. So this would actually be our number. Now, if you're really good with your math, you might know you could turn that into scientific notation. It would actually look like this. You do not have to be able to do this for my class. It would be 2.1 times 10 to the negative 1, 2, 3, 4, 5, 6, 10 to the negative 7. This would actually be our answer in scientific notation. I might change this one in class and make the number even a little bigger so you don't get such a teeny, 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 tiny number. So if this doesn't match the one we did in class, that's why. All right, let's look at this last one. Micro to pica. Okay, so let's look at what direction we're moving. Let's try this light green. I don't think I used that. So micro is here, pica is here. So it's going to the right. But remember, these are the 3 decimal place jumps. So we're going to go 1, 2, 3, 4, 5, 6. So 3, 3, 6 spaces to the right. So 1, 2, 3, 4, 5, and we'd add a 0. So it would be 610 picoliters, and that would be our final answer. So that's how you do basic conversions. Hopefully that's a good practice. Let's just run through some of these units real quick. So mass is the amount of matter in an object. Usually we kind of think of it like weighing stuff, even though it's not exactly the same thing as weight. But for purposes of our class, if they asked you to get the mass of something, you'd put it on a scale. The SI unit is kilograms, but usually in class we would use grams on the digital scales. Length is how long an object is. Everybody knows length. The SI unit is the meter, but if you were measuring a long distance, you might use kilometers, like the distance to school would probably be kilometers. But if you were measuring something smaller, it might be centimeters or millimeters, or if it's like under a microscope, like bacteria or viruses, micrometers, nanometers, picometers. They're really, really small prefixes. Volume is the amount of space an object actually takes up or occupies. It's length times width times height to give you volume. The SI unit is called a cubic centimeter because it's centimeters times centimeters times centimeters. But for liquids, we often use milliliters. And 1 cubic centimeter is 1 milliliter. And lastly, temperature. It's the measure of energy. And you're familiar with Celsius, but but the SI unit is actually Kelvin, which has no negative numbers.